Okay, so now we're going to look through specific charge. So specific charge is a very basic topic right at the start of your AS spec in your particle and radiation module. So specific charge, the word specific is actually more general than it seems. Specific just tells you that this is per unit mass. Okay, whenever we have anything that is a specific value, it means that it's that value of 1 kilogram of that thing. So things like specific charge is per mass, things like specific heat capacity would be per mass as well. So anytime we see specific, it means per unit mass. Charge just means charge. So this means that this is going to be charge divided by mass. And that's it. That is your equation that you need for all the specific charge questions. This is one of the very few equations that you aren't actually given on your formula sheet. So you do have to remember this, but luckily it's quite straightforward as long as you know that specific means per unit mass. So then specific charge, they'll ask you questions such as calculate the specific charge of this ion or this nucleus or stuff like that. They won't really ask you to calculate the specific charge of a proton or a neutron because these are values that are given in your data sheet. But let's take an example. Let's say we have alpha radiation. And alpha radiation, we should know that alpha particles are a helium nucleus. So helium has 2 protons and 2 neutrons, and it's just the nucleus, which means we're only taking the charge of the nucleus. So we have 2 protons in the nucleus, which means if we want a value for specific charge, those 2 protons are the only thing that carries charge in the nucleus. So we have 2 times 1.6 times 10 to the minus 19, because this is the charge of a proton in coulombs, divided by the total mass of this nucleus. Now you can split this up into the mass of a proton and mass of a neutron by having 1.675 as the neutron and 1.673 as the proton, but you don't really need to do that in these questions because that 0.002 times 10 to the minus 27 kilograms isn't going to make much difference to your answer. So you can just say it's 4 times 1.67 times 10 to the minus 27. This is your general mass of both the neutron and the proton. And then you put that into a calculator and that's your answer. And your answer will come in units of coulombs per kilogram, because our charge is in coulombs and our mass is in kilograms, and so we're dividing them, so coulombs per kilogram. And this is a very straightforward topic. All the questions will be the same. They might give you different values. They might say it's a xenon plus ion, in which case you know your charge isn't going to be all of the protons in the nucleus, it's then just going to be that 1 plus. And so your specific charge for this would just be 1.6 times 10 to the minus 19 divided by the mass of xenon, which is your protons and neutrons. So now let's have a look at an actual exam question. So now this question says nucleus X has the same nuclear number as nucleus Y. The specific charge of X is 1.25 times greater than that of Y. And X, they've told us, is boron 10, and they want us to deduce the number of protons and neutrons in Y. So the first thing we can do is, since we know the number of protons and neutrons in X, we can then work out the specific charge for the nucleus X. So we say that the charge of nucleus X is only coming from the protons. And we know we have 5 protons, so 5 times 1.6 times 10 to the minus 19 divided by the total mass. We know we have 10 nucleons, each with a mass of 1.67 times 10 to the minus 27 kilograms. And this is our specific charge for nucleus X. Then we want the specific charge of nucleus Y in order to make out what the number of protons and neutrons is going to be. So if we take this whole number, given that X is 1.25 times greater than Y, in order to do the opposite, we want to divide this value by 1.25. Once we divide that value, this whole thing, if you put that into a calculator, will give you your value for the specific charge of Y. And now that we've got the specific charge of Y, we can then say that if we then want a value for the number of protons and neutrons, we can say this is then equal to X being the number of protons multiplied by 1.6 times 10 to the minus 19, still divided by 10 times 1.67 times 10 to the minus 27, purely because we know that they have the same nucleon number. So we know they still have 10 nucleons and all nucleons have this mass. And so we take this, we find out what this value is, and then we will have to say this is equal to some value. I'm going to call this y. Then we say that's equal to whatever this value is. And then in order to get x, we can rearrange this to say that x must be equal to 10y times 1.67 times 10 to the minus 27, all divided by 1.6 times 10 to the minus 19. That gives us our value of x. Remember, y is this value here. And so these are all numbers that we know. We can just put that into a calculator. That will give you your answer for x, x being the number of protons. And since we know the number of protons, we can then work backwards. We know that they've both got 10 nucleons. And so if we do 10 minus the number of protons, it will give you the number of neutrons. And that's the question done, okay? The reason I chose this is because this is possibly the most difficult specific charge question you're gonna get. Most of them will stop at maybe the first step. This one takes it a bit further. It's not so much a test of your understanding of physics, it's more a test of your understanding of math. So remember, you need to still be hot on your math skills in order to get good grades in A-level physics. But yeah, that's specific charge. If you have any questions, leave them in the comment section below. If you want to see any other topics for us to go through, also leave them in the comment section below. We have also released videos going through 2 AS papers that you can go back and see, and A-level papers are coming soon. So yeah, thank you.